Okay, in this question it says the overhead reach distances of adult females are normally distributed with a mean of 205 centimeters and a standard deviation of 8.6 centimeters. So in part A, we want to find the probability that an individual distance is greater than 214.3 centimeters. So we're finding the probability of an individual value being greater than 214.30. And we know that the mean is 205 and the standard deviation is 8.6. So if I draw my normal distribution off to the side, I can see that the mean is 205. We're looking for the probability of getting a value over 214.3. So I'm going to guess that's roughly about here. And this is the area that I'm looking for. So I know that I'm expecting something less than 50%. I'm going to use the normal CDF function because I'm trying to find a probability. And I start at 214.3. And my upper limit, there is no upper limit, so that's 1E99. And my mean is 205. And my standard deviation is 8.6. So when I put this in the calculator, I get 0.1398. And that's rounded to 4 decimal places. In part B, it says find the probability that the mean for 15 randomly selected distances is greater than 203.5. So it says the mean. So we're looking for the probability that the mean of 15 values is greater than 203.5. So in this case, I need to use mu sub x bar, which is just mu, and that's 205, and sigma sub x bar, which is sigma over the square root of n. And sigma was the 8.6, and n is 15. So this one does not work out very nicely. Sometimes your sample size is a perfect square, and you can take the square root easily. In this case, it's not. So when I put this into the calculator, and again, I'm using the normal CDF function because it's calculating a probability. And my lower bound is, in this case, 203.5. And my upper boundary, there really isn't one, so we use 1E99 to represent infinity. And mean is 205. And for standard deviation, I'm just going to type in 8.6 divided by the square root of 15. So when I put that in the calculator, I'm going to get 0.7503. If we look at this, we've got our mean is at 205, and 203.5 is going to be pretty close here, 203.5, and so this area turns out to be about 75%. So that works. And then in part C, it says, why can the normal distribution be used even though the sample size was not greater than 30? And the reason why is because the values, we were told in the beginning, are normally distributed. So if you don't have a sample size of more than 30, then you're looking for the values to be normally distributed. And that means you can use that central limit theorem that we used here. So that's how you do those problems.